All right. Functions. Well, let's start at the very beginning because I really don't know how much you guys remember or how much you guys purged from last year. Do you guys know what a function is? Like if I show you a graph, can you tell me if it's a function or not? Yeah. Okay, here's the graph. Wow, is that a function? No, so what is it then? What do you just call a set of ordered pairs, or basically any graph? It's called a relation. Oh boy. How do you determine if a relation is a function? What did you learn last year? It has to pass. Really? The vertical line test. Come on, have you guys heard of that before, the vertical line test? Does this pass the vertical line test? Every vertical line I draw, it will intersect the graph at most once. No, that's how you tell if something's a function. That's not the definition though. A function, by definition, is for every x value, there is at most one y value. And then what do you call a relation that passes both the vertical and the horizontal line test? Come on, Mr. Rubash said he'd spent like a week on this. It's called a one-to-one function. You guys heard of that before? So a one-to-one function passes both the vertical and the horizontal line test. So something like this. Does that pass the vertical and the horizontal line test? Yeah, in fact, that's a function familiar to you from last year, right? Isn't this like a log graph, like y equal natural log x? Oh boy. Okay, now, because tonight's homework, you're going to have to know some base graphs now. These are all graphs that you're supposed to know. Y equal x squared, y equal x cubed, square root of x, 1 over x. What about this one? Do we know this one? Square root of 1 minus x squared, that's a semicircle. Okay, why don't we go over it now then? Y equals square root of 1 minus x squared. That is a semicircle of radius 1. That's an ugly semicircle. Anyway, does it pass the vertical line test? Yeah, so it's a function. Does it pass both the vertical and the horizontal line test? No, so this is not a one-to-one function, it's just a function. Anyway, so whenever you have a function, let's go through the things over there. Number one, if I give you a function, you should be able to tell me if it's odd, even, or neither. Did you guys learn about even and odd functions last year? It doesn't matter because I'm going to teach you now, right? What is a definition of an even function? F of negative x equals f of x. If you plug in negative x into the original function, you get the same thing with what you started with. And an even function is always symmetric about the y-axis. Some of you are looking like, I don't think we learned this before. I think you did. Okay. What about an odd function? F of negative x is equal to negative f of x. If you plug in negative x for x, you get the opposite of what you started with. And an odd function is always symmetric about the origin. See, you guys are starting to remember. Okay, so, let me do one. I'll do, which one looks, I'll do B. 1B. F of x is equal to x cubed plus x. How do you determine if this is even, odd, or neither? You plug in negative x for x, like this. Now, after a while, you can just do it in your head, because this is really easy. Plug in negative x for x, now simplify it. How do you simplify this? Okay, I'll do it. Is that the same as the original function? Is it the opposite of the original function? Opposite means you multiply by negative 1. How come some people say, no, yes, this is the opposite. If you multiply this whole thing by negative 1, don't you get this? This is an odd function. Now, when you take the AP exam next year, this is going to be 2 points on the free response. Is this even or odd? Okay, odd, you get 1 point. You want the other point, then you have to explain why. Now, you cannot say things like this. If you plug in negative x for x, you get the opposite of what you started with. No, on the AP exam, they want you to refer to definitions and theorems. So what is the definition of an odd function? So you would say it's odd because f of negative x equal negative f of x. And there's the work that supports it. Okay, I can guarantee you this problem is going to be on your next quiz, which is on Thursday. Is it Thursday or Friday? One of those. I guarantee that's on there. Okay, what if it came out even? Then what do you say? Because f of negative x equals f of x. You got to state the definition. I'm trying to train you for BC calculus, or any calculus for that matter. Okay, number 2, find the domain. Okay, this is easy. Okay, in fact, I might do 2 problems from here. 2A. This one is so easy, even my dog can do it. Is this the class I showed my dog when we did it? Oh, okay, I can't remember what class it was. My dog just happened to be passing by, and then he did a problem, or she did a problem, and then she went back to sleep. Okay, how do you find the domain? When you have a fraction, you just have to make sure the denominator is not 0, because you cannot have 0 in the denominator. So the domain is, what am I doing? X such that x cannot equal 5. Now the reason I put a set there is because by definition, domain is a set. Now on the AP exam, the AP people, they don't really care about like technical math. But if you want to technically be correct, that's what you would have to write. Or you could do this, negative infinity to 5, and then 5 to infinity. Basically, anything that's not 5, right? Okay, well, what about when you have a square root? Like, for example, oh, I don't want to, okay, I'll do that. 1f then, 2f. I'll do the hardest one, although it's not hard at all. Square root of x over 2 minus x. Okay, pretty much this might be on the next quiz too. How do you find the domain when you have a square root? Well, whenever you have a square root, the inside has to be not just positive. Can it be 0? Yeah, so it has to be greater than or equal to 0. If you square root a negative number, you're going to get imaginary, but again, we're only working with real numbers here, yeah? So, whenever you see a radical, whatever's inside, just make it greater than or equal to 0. If you solve this inequality, that would be your answer. Now, do we know how to solve inequalities? Yep, you just took a quiz on it. So what do? You make one side 0, it is. You factor this side, it is. You're ready for the number line. 0 and 2. Is 0 part of the solution? Yeah. What about 2? No, because it's in the denominator, right? Denominator can't be 0. And then is this a plus minus plus or a minus plus minus? This one is a minus plus minus. How come? Because the leading coefficient is negative. Anyway, if you don't know, plug in a number bigger than 2, like 3. 3 is positive. 2 minus 3 is negative. Positive over negative is negative. And since you have odd powers, it's going to alternate, right? Now what do I shade in, the plus or the minus? The plus. So your domain is from 0 to 2, including 0, but not 2. Easy, yeah? Okay, but what's harder is find the range. Do you guys even know the difference between domain and range? Okay, then you know what? I'm gonna have to check to see if you make sure. Okay, look. Here's a semicircle of radius 1. Okay? What is the domain? The domain is a listing of all the x coordinates. Like right here, what is the x value right here? Negative 1. There it's 0. There it's 1, right? Do you have everything in between? So the domain is from negative 1 to 1, inclusive. What about the range? A range is a listing of all the y coordinates on the graph. What's the smallest y coordinate on the graph down here? 1. Oh yeah, 0. And what's the biggest up here? 1. So, and you have everything in between too? So the range is from 0 to 1. That's the difference between domain and range. Now to compute the domain and range, domain is easy. If it's a fraction, just make sure the bottom's not 0. If it's a radical, the inside gonna be greater than or equal to 0. But what do you do about range, Mr. Park? What do you do? Well, if you have the graph, it's easy to tell, right? But then look at these. Do you guys even know what the graphs look like? Well, actually, 3A you do. I'm gonna do 3D for you. That's because this is the level that you're gonna see on the quiz right there. Did you guys even, does anybody even know how to graph D? Actually, this is the kind with the, remember, this is what we're gonna learn next chapter. Remember the vertical, horizontal, and slant asymptotes? That's what this is. But you guys probably forgot how to graph it, yeah? Anyway, so to find the domain, what did we do? We solve for y and look for restrictions on x. So to find the range, what do you think I'm gonna do? I'm gonna solve for x and look for restrictions on y. So what you have to do is you have to take this equation and change it into x equals something using algebra. Okay, so how do I solve for x? What do I do? Any suggestions? This is just algebra. How do I get, okay, come on, this is algebra 1. How do I get rid of the fractions? Multiply both sides by the LCD, which is x. Okay, do that. Oh, there's an x squared here. There's an x here. So what you need to do is put this into quadratic form. Going back to ln quad. Okay, so make one side 0. Notice how I make my first term positive. X squared minus yx plus 1. See? Something x plus, something x squared plus something x plus something. This is called quadratic form. How do you solve for x now? How do you solve for x? It rhymes with quadratic formula. You use the quadratic formula, so how do you think I'm going to solve for x here? You use the quadratic formula. Now, you're going to be doing this multiple times on tonight's homework now. So that's why you need to put it in quadratic form. Once you have it in quadratic form, okay, here's A, B, C. Throw it into the quadratic formula. X equals negative B, I even write it out, plus or minus the square root of B squared minus 4AC all over 2A. I didn't skip any steps. Okay, now what did we learn? How are we going to find restrictions on what y is? Well, if there's a radical, what did we learn 2 minutes ago? If there's a radical, the inside has to be what? Greater than or equal to 0. So I see a square root. Whatever's inside has to be greater than or equal to 0. If you solve this inequality, that is the range. Do we know how to solve inequalities? Yes, Mr. Park, we just took a quiz on it. Okay, make one side 0. Factor this side. Look, I'm not making it difficult, you know. Factor this side and then make a number line. Oh, it's very mechanical. Is negative 2 and 2 part of the solution? Yes, because of the or equal to, right? And this one is plus minus plus. How do I know that? Because the leading coefficient is positive. Anyway, like I told you, if you don't know, just plug in a number bigger than 2, like 3. 3 plus 2 is positive. 3 minus 2 is positive. Positive times positive is positive. And how do I know they're going to alternate? Because you got odd powers. And what do I shade in? The pluses or the minuses? Yeah, greater than means you shade in the pluses. So the range for this problem is from negative infinity to negative 2, and then from 2 to infinity. There you go, that's how you find the range. Just the opposite of finding the domain. You solve for x instead of y. I don't like this one, Mr. Hart. Well, I pretty much, this is on the quiz, I'll tell you right now. 100, probability of this problem being a, probability is 1. You know what that means, right? Garens, ball bearings, it's on there. Okay, let's move to the next problem. Find the range. Which are of the following functions are one-to-one? Okay, those are all base graphs. You just look at it, or just think of the graph in your mind. What does one-to-one mean? It has to pass both the vertical and the horizontal line test. Okay, let's do one of them. We kind of did E, we'll just do it again then. 4E. What is this graph again? Rhymes with hemicercle. It's a semicircle. The square root of this number is the radius. I'm not going to even ask if you guys learned it last year, because there. Does that pass both the vertical and the horizontal line test? No, so it's not one-to-one. See, notice that I'm only giving you base graphs. Do you guys even remember? Oh, do we need to review? Do you guys know what y equal 1 over x looks like? Say what, girlfriend? Come on. This is on the inside cover of your Algebra 2 book. It looks like this. Okay, look at it. Does it pass both the vertical and the, well, of course it passes the vertical line test because it's a function. How do you know it's a function? Because I said it, look. If you use this notation, you're saying it's a function. So does it pass the horizontal line test? Yeah, so this is a one-to-one function. What about square root of x? Do you guys remember that graph? You guys are scaring me. Anyway, if you don't know what a base graph looks like, what did your teacher tell you? Plot points, right? Plug in 0, plug in 1, plug in 4, plug in 9. Man. Does that pass both the vertical and the horizontal line test? Yep, that's one-to-one then. Why am I doing all the problems for you? Okay, I'm not going to do number 5. Okay, let's go on to number 6. Okay, probability 1. This problem is on the quiz. And I'm going to do a problem that's almost exactly like it. Well, they're all almost exactly like it. I just changed the numbers. Okay, what do you do when you see absolute value? Hey, pretend it's not there. Don't do that because that's a fatal error. Skip to the next problem. Or C. Make a piecewise function. Yes, that's the one you do. Remember I told you absolute value is a piecewise function. So, dude, that's what you do. Now remember, how does absolute value work? You guys did the homework, I hope. If the inside is positive, you leave it alone. If the inside is negative, you negate it. That's how absolute value works. So when will the inside be positive? When x is greater than 1. Yeah, but Mr. Park, you usually write or equal to. How come not or equal to in this problem? How come x cannot be 1 in this problem? Because it makes the denominator 0. Okay, and then x is less than 1. So if x is greater than 1, then the inside is positive, right? Think of a number bigger than 1, like 2. 2 minus 1 is positive. So what do? You leave it alone. There's only 2 things you're going to do. You either leave it alone or you negate it. That's all you're going to do. So since x is greater than 1, it's positive, you leave it alone, like that. And then when x is less than 1, like 0, 0 minus 1 is negative, what do? You negate it. There you go. Mr. Park, we don't know how to graph that. That's next chapter. Yes, you do. Because it cancels. Can't you simplify this to x plus 1 times x minus 1? X minus 1's cancel out, and what are you left with? X plus 1. Oh, now I know how to graph that. That's a line. Yeah, I'm not gonna give you something complicated till next chapter. Okay, and then when x is less than 1, what about this one? Same thing. Factor it, cancel, and what's left? Negative x minus 1, right? Don't forget to distribute the minus sign. Hey, that's a line. I know how to graph lines, monsieur. Okay, so do we know how to graph the line y equal x plus 1? Okay, here, let me give you a little, this is what I do when I graph piecewise functions. You see this number here? I simply plug it in here. What do you get? Really? 1 plus 1? 2. How come I put an open circle there, not a dot? Because it's greater than 1, not greater than or equal to. And then what's the slope of this line? Look at this number there, 1, so there, slope 1. You're just sketching. Okay, then what I do is I take this number and I plug it in here. What do you get? You get negative 2, open circle. And what's the slope of this line? Negative 1. There you go. Right, you guys know how to graph lines. Now, of course, if it's not lines like the last one, problem 6C, you're going to get parabolas. So hopefully you remember how to find the vertex and all that stuff. Okay, but the one I'm going to give you on Thursday or Friday's quiz, whenever it is, it's going to be lines. You guys can handle lines, right? Okay, what time is it? Oh, we only got 5 more minutes. Okay, this is the last thing we're going to go over then. Look at number 7. This problem is also on the quiz. You don't even have to ask. Now, you might remember this from last year. I'm going to give you a function. Okay, let's x cubed. So all I'm going to do is I'm going to change this function. I don't know what I'm going to give you. But no matter what function I give you, you have to be able to compute this. F of x plus h minus f of x all over h. Does that sound familiar from last year? Yeah, you know what this is called? Come on, somebody impress me. It's called the difference quotient. Does that word sound familiar from last year? I think it was in the directions in your book. Compute the following difference quotient. You know why they call it the difference quotient? Because look, there's a difference and there's a quotient. And you know why it's so important? You know why they give it to you and then I'm giving it to you again? All of calculus is based on this. If you cannot work with this expression, you cannot do calculus. Okay, so I can give you any function. You should be able to form the difference quotient. Okay, so let's break it up into pieces. We got 4 minutes. F of x plus h. You guys know how functions work, right? Whatever's in the parentheses, you plug it in for x. So f of x plus h means plug in x plus h in there, right there. Right? Minus f of x is the given function. And then you divide the whole critter by h. Okay, now that's the easy part. Now you know what you have to do. Simplify it. Because if you can't simplify it, you can't do calculus. So how do I simplify this? And if you remember anything from last year, doesn't this simplify to something kind of nice? No, Mr. Brook, I just skipped this problem on the quiz. Okay, multiply out x plus h cubed. Hey, binomial theorem. We just learned it. Or just remember something, Pascal's triangle or something. Come on. Okay, I'm just going to do it because we're running low on time. Mr. Park, how did you know it was 1331? Pascal's triangle. Over h. X cubes cancel out. Can I factor out an h on the top so I can cancel it with the h on the bottom? Now, if you remember anything from last year, you know this h on the bottom is going to cancel out, right? I don't remember anything from last year this year. So factor out the h. They cancel out. It will always cancel out. That's the beauty of this. So your final answer is 3x squared plus 3xh plus h squared. Box that, that's the answer. If you cannot do that, you cannot do calculus. I guess I can't do calculus, Mr. Park. That's why you gotta practice your algebra. This is your third year of algebra. We gotta get good at it. Okay. We're done. I will see you on Wednesday. On Wednesday, be prepared to graph. Pretty much the whole homework is just graphing, 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 graphing.